All right, I guess I'll get started with today's seminar. I'll be introducing the speaker from the NC's Lounge. Welcome and thank you for joining us for our fifth annual NC's Spring Seminar Series. Today we have the pleasure of welcoming Bonnie Lay, our third and final speaker in this series. This year, our series is focused on the theme of leveraging AI for environmental good. I'm Erica Nielsen. I'm a research fellow with the Nature Conservancy and NC's. I'm joined by the rest of the seminar series planning committee, Justin, Angie, Christina, Erica, and Nicole. At NC's, we work to accelerate scientific discoveries that enhance our understanding of the world and benefit both people and nature, as well as transform the scientific culture to be more open, efficient, and collaborative. Before we begin, I would like to ask you to join us in acknowledging the Chumash peoples who are the environmental stewards of the land on which NC's is located. We pay our respects to the Chumash peoples and their elders, past, present, and future, who call this place their home. We acknowledge that this land on which we live and work are the traditional homelands of Indigenous peoples, including the Chumash. This land today is the result of the erasures and exclusions of Indigenous peoples. As we come together to bring awareness to the issues of equity and justice, we recognize that the Chumash people and so many other Indigenous people are still fighting to dismantle the legacies of settler colonialism in their tribal territories. As we continue to work towards diversity, equity, inclusion, and justice in data science, we strive to prioritize Indigenous data sovereignty and self-determination. All right, so now for a few logistical things. For all of you joining us for this webinar, please feel free to ask questions throughout the talk online through the Q&A button located at the bottom of your screen. We will have a moderated Q&A session at the end of the presentation. We also have some folks joining us here in the lounge, so we can take questions in person also at the end. Now I'd like to introduce our speaker. Bonnie Lay is a principal of the Carbon Markets Initiative within the Rocky Mountain Institute's Climate Intelligence Program. She leads a team that leverages technology and data to enhance the transparency, quality, and equity of the voluntary carbon market. Previously, she was head of the environmental justice, employee engagement, and ecosystems at Microsoft. She was also a founding member of the Microsoft AI for Earth and helped build the first planetary computer. Bonnie started her career as a conservation biologist, helping initiate the Wildlife Conservation Society's marine program in Myanmar to discovering a new sea slug species in the Caribbean. Bonnie, we're really excited to have you, and now you can begin. Thanks.
Oh, thank you so much for the lovely introduction. And it's so good to get to be with all of you today. I see there's some of you who are physically in the room, others of you who are virtually dialed in. Big hello to all of you, and really excited to get to share a little bit more about what we are working on at RMI, focused on carbon markets. But I thought it actually might be nice to kick off by giving you a little bit of context for how I got to here. Because as you sort of heard from my intro, I sort of dabbled in lots of different pieces. So how did I ultimately end up working on carbon markets? So, and I think that sort of pathway also gives a little bit of a sense of how the interrelated components of data and technology have increasingly been something that I've been really excited about leveraging as a tool to work on solving some of these challenges that have really been interesting to me. And so I actually, like was mentioned in the intro, started off as a conservation biologist. So that's what I had studied, and I had worked directly in conservation field biology in a number of different places around the world, and working on a range of different species. Here is one example. This is going all the way back to my undergraduate time, where I was working together with the University of Cape Town researchers to try to determine how African penguins were reacting to climate change. And so this involved helicoptering in with the research team to this tiny little uninhabited island off the coast of South Africa that happened to have the largest population population of breeding African penguins, where we were able to do all sorts of studies to understand how both the adult birds as well as the penguin chicks were reacting to different temperatures on land and in the water. Another example is when I was working with the Wildlife Conservation Society in Myanmar. And this was where I was really excited to have an opportunity to go to Myanmar, where my grandmother is originally from, and to be working in helping to start up their marine research program. And this involved working really closely and living with the local fishing communities to really understand what changes in behavior had happened and what is really required to be able to allow them to set up sustainable livelihoods for themselves without having to resort to things such as fishing for illegal fishing for endangered shark and ray species. I think one of the things that I experienced a lot in the field is this frustration around that some of the work that we do felt like it was really resource intensive, or it felt like we were getting to something just a little bit too late. So here's an example that I could show you. This is still when we are working in Myanmar, where again, where the marine program was really focused on trying to circumvent and stop the illegal fishing of the endangered shark and ray populations. Um, and while we were doing the work, we would oftentimes come across something like this, which is we come across this very, very large catch of vulnerable eagle rays, but we only happen upon the scene when the rays have already been caught and processed and the parts are drying in the sun and good. And so I think this really was something that I thought a lot in the back of my mind around there's got to be ways that we could be using new tools or taking new approaches so that we could make sure that the conservation work that we are doing on the ground is able um, to be done even more quickly, to be done even more effectively, so that we avoid a situation where we are stumbling upon something when it is already too late, and this is an irreversible situation. And so that really is what led me to a path that I definitely had not put on my bingo card or expected in my career when I started off, very much deeply in the world of research and conservation biology. And that is that I ended up working at Microsoft. Specifically on Microsoft's sustainability team. And I joined at first, even more specifically, to start up this program that they had called Microsoft AI for Earth. And the reason why I ended up there is I was wrestling with these questions in my mind about what ways we could um, work towards more effective on the ground conservation. And I wanted to figure out what are some of these tools and techniques that we could leverage. And that's really where Microsoft was also interested in wrestling with those questions, and specifically around how their AI and cloud computing functionalities actually could be applied in environmental and sustainability situations. And so this program has really started to focus on working to empower the people and organizations who are on the front lines of doing sustainability work in a range of different topics, inclusive of the biodiversity conservation work that's so close to my heart, and really be thinking through like, hey, how could we work hand in hand with some of these researchers and scientists and innovators to be able to leverage these AI and compute power that Microsoft has been developing, just not for this specific use case of environmental needs. And so, when working on getting this program started, what we were able to do is actually set up a granting and partnership program. And over the course of AI for Earth's tenure, I had the great privilege of working with more than 800 different projects located in places all over the world. I could again talk talk for hours and hours about all of the great things about all of the projects and what they were able to accomplish. But I'll give you just two little tidbits. Again, as you saw from my previous work, these were two examples that were particularly close to my heart, and I think really give some good a good example of some of these different ways to deploy AI. So the first example I'll talk about is this work by Dr. Heather Lynch, based at Stony Brook University. She works on penguin populations. In this example, she was specifically working with Adelaide penguins in Antarctica. As I described to you, when I was working on penguin field research, it is incredibly resource intensive to actually try to go to where the penguins are and be able to do some on the ground, in person surveys and monitoring of those of the penguins. And I wasn't even working on the Antarctic species. And as you could imagine, with Dr. Lynch and what she was trying to do in Antarctica, really, really resource intensive trips that need to be planned to be able to do the surveys and understanding of where the penguin populations are and where they're growing and how they're moving and changing. And so we were able to work together with her, and she received one of Microsoft's grants to actually use computer vision and empowered by AI, made more effective by AI, to actually be able to detect penguin populations using remote sensing, so without having to send any person on the ground. And so she wanted to be able to, again, her major research question really wanted to be able to just understand changes in population and movements of populations of the Adelaide penguins over space and time. And her first use approach was actually trying to look at some of this aerial imagery and try to be able to have the AI model trained up to be able to identify individual penguins in an image. And what she found quickly was that that actually was quite difficult. AI can't actually do everything, unfortunately. You still need to be able to think through, it's like, how could you actually get error rates that are low enough so that you actually get useful outputs? And so in this case, what she was able, through some trial and error and testing, was she figured out that actually what is much easier to detect and is a really good proxy for where penguins are is not necessarily trying to pick out the penguins themselves from the image, but actually looking at their poop or their guano stains. So on the left side, that's what sort of looks like a dark brown color in the image. And so you could actually see these stain patterns across the snow and ice. And it's actually much easier to be able to train up a model and be able to detect a larger poop stain. And again, very good proxy for where penguins actually are. And so that's exactly what she did. She was able to train up this AI model to be able to do that automatic detection, use that as a proxy for being able to track the penguin populations she was interested in, and be able to proceed with her research in a much faster, much cheaper way. Another example that I also really, really enjoyed coming out of my Myanmar work, working on trying to circumvent illegal fishing efforts, we were able to work together with a nonprofit organization called Ocean Mind, which is based in the UK. And what Ocean Mind does is they are focused on trying to increase the sustainability of global fishing efforts by being able to track down and call out and ultimately prevent by partnering with various enforcement agencies illegal fishing. And so, how are they able to do that? What they do is that they use remote sensing to be able to actually look at a an ocean area, and they're actually able to look at and document and diagram out the different movements of different vessels that are in the ocean. And so this is a combination of satellite imagery. They're also using sensors by looking at sonar and GPS. And so from all of this, they're able to show essentially diagram out like this is how all of these different vessels in this area of water are moving around. They were able to create this AI algorithm that actually is able to detect and say, like, hey, this is how a vessel of this type is likely to move. And if a vessel is doing something that is odd, they could flag that and mark that. And that's something that they could actually, working together with different governmental agencies, actually send out patrol boats to be able to target the vessels that are moving in the ways that are most likely to be to be veering away from normal behavior. And so what Ocean Mind has been able to do with this algorithm that they've created and working together with various different governments around the world is not only tamp down on cases of illegal fishing vessels that are harming endangered species or doing large catches that are over catches that's more than is allowed. They've also found that these approaches have been incredibly important in being able to cut down on cases where there are human slavery incidents on board, where again, there's a lot of cases where the illegal fishing vessels are also the ones that are using illegal slave labor to be able to actually run the ships. And so it's a case where it's a combination of not only the environmental impact, but also the human rights impact that was incredibly impactful by being able to work together with Ocean Mind and think about the technology that they're able to leverage. I'll talk about one more example that I worked on back when I was at Microsoft and AI for Earth, and that is Carbon Plan. So this is a project where I was able to really start to get exposed to carbon crediting projects and really start to understand some of the opportunities as well as the challenges that exist in this space. And so, big picture wise, what Carbon Plan is able to do is that they're able to do a combination of both forward looking or what we sort of call like a planning type or of application, as well as a backwards looking, past looking, or diagnostic type of application. High level for those of you who are not aware of forestry carbon projects. So carbon projects as a whole are really intended to be able to account and put in clear numbers, a type and put value on types of activities that are able to either remove, reduce, or avoid greenhouse gas emissions into the atmosphere. And so forestry projects are one category of carbon credit types that's really focused on either planting trees, avoiding deforestation of trees. And one of the challenges that have come up in this specific project type around forests is that there could be issues that are unfortunately more common nowadays around things like wildfire. That actually, it's like if you plant a stand of trees and then we're planning to indicate that this is a way to be able to have the trees photosynthesize and take and actually remove emissions from the atmosphere. After a wildfire happens, then you no longer have that capability, and that project is no longer legitimate. And so that's something that as folks are trying to determine what projects to buy, and as well as project developers who are trying to determine what is actually a realistic number that they could feel correct about crediting. They really want to be able to have a combination of monitoring as well as modeling efforts. And so that's what Carbon Plan is able to do. Again, all of this done remotely with a combination of AI models running on the background. They're able to project forward into the future by being able to take into account the past, the risks of either wildfire, various pest infestations, etc., on forest stands in different areas using a combination of past data as well as modeling for various climate scenarios, and be able to use that to plan into the future to allow buyers to think through where they want to purchase credits, as well as for project developers who are interested in thinking through which areas will make the most sense for them to develop projects. And then in looking back, that's something that is increasingly more common now, to be able to help validate a carbon project is real over time, is to actually quantify what actually has happened and make sure that the accounting of the credits reflects that. And so that's what they're able to do too with their retrospective diagnostic application, is to be able to take all of their monitoring data over the a project's lifespan and be able to quantify what is the true carbon credit value and amount that you could credit for. And so I think that was an area that I first got increased exposure into carbon markets. And I increasingly became interested in thinking through beyond just using data and technology for being able to advance sustainability conservation work, I really wanted to figure out how we could direct financing to the good, real sustainability work that is deserving of the funds. And so that really is what got me to make the switch over into working in carbon markets, specifically now at RMI, because carbon markets and the carbon credits really do serve as a mechanism for being able to direct funding towards sustainability work that is happening on the ground. Um, the challenge, though, of course, is that this all works. The market as a whole works. Is you need to be able to reward and put value and give money to the credits who are doing the real things. And if you guys have had any exposure to carbon credits in popular media or in the public media recently, it probably actually was a case where it was an instance of fraud in the system where there was a project that was claiming to issue credits of a certain amount, and the forest was never planted, or the forest was never actually at risk. And so having people pay money for that actually isn't a valid use of a credit. And so I think that really was a thorny issue that I became interested in figuring out. Is there a way that we could think through how we could leverage data and technology to work on tackling some of these fundamental issues in the voluntary carbon market, and get it to a place where the carbon market could actually function for real, and that we could have confidence that all of the credits that are purchased and retired actually are directly supporting and enabling climate action on the ground. And so, a couple of the different areas where we faced challenges in the VCM. One is this category of what's called information asymmetry, or the fact that you have multiple different stakeholder types within this market that have varying degrees of access to the data that's needed to actually know whether or not a carbon credit project is performing. So, as like one example is you have specific players in the market that are called ratings agencies. And ratings agencies' job is to put a grade or a rating on a project, and that grade is then an indication of that agency's judgment on how well a project is performing. And so if you want to buy a project, you would think like, hey, I could just pick all of the ones that are rated A, and I should feel good about that. But what's a little bit tricky is that ratings agencies' business models is built on proprietary models. And so they don't actually tell you how they got to the grade that they're issuing. And so that lack of transparency means that when you actually have ratings agency give you very different scores, you don't actually know who to trust because you don't understand how they came to give that rating or that grade. Or if you know that you're a buyer that has very specific preferences, you don't actually know how much that aligns with this rating agency or another. Another example of where data could get really tricky in the VCM space is that when the project developers who are on the ground creating the projects, the format for being able to summarize all of the information about a project is what they call a project development document, or a PDD. And this is a hundreds upon hundreds of pages PDF document that is created with all sorts of nested numbers and data. And this still is that is still the most common format that is uniform across every single project. And as you can imagine, that's something that's incredibly difficult for you to actually figure out how to pull out all of the numbers that you care about and be able to compare it with another project where you're fishing again through hundreds of pages of PDFs. Um, all of this makes it really time intensive, and it's really difficult for you to have a full picture of how one project compares to all of the other available project types in the system. So, what we're trying to do at the Rocky Mountain Institute through our Carbon Markets Initiative is really to work on building more trusted, transparent, and interoperable carbon markets across the board. To do that, we have one scope of work that's completely focused on working on all of the data challenges, on sort of wrangling and figuring out how we could get the data to actually function effectively behind the scenes. And then on the other side, we also work with buyers and other market stakeholders to figure out how can you actually interpret that data and use it for your decision making in a insightful way. And so on one side, we're trying to push as much data out into the open as transparently as possible, not hiding behind black boxes or deeply buried within PDFs. We want to be able to have it completely freely, easily accessible in the same format. And then once we push all of that great standardized, formatted, open data out, we then need to help equip buyers and other stakeholders with the skills so that they actually know how to use that data and then make wise purchasing decisions. I will focus mostly on the data side for the rest of our time together today. So happy again, if you guys have further questions, feel free to get in touch with me, and I'm happy to chat more about the demystifying side as well. So to dive a little bit further, I wanted to highlight, I heard that you guys, again, are quite interested in understanding the combination of sort of various data tools as well as AI tools. And so I did want to share this report out from a VCM landscape guide that the team created. And so this guide is really focused on if you're interested at all in learning more about carbon markets. This is a very comprehensive, very deep dive into explaining how all of the different components of the voluntary carbon market works. And we also break down and talk about some of the various challenge areas as well as opportunity areas. So again, to share out just this one section of the broader landscape guide, we did analyze and try to understand how various digital tools could actually be helpful for bringing greater efficacy and trust to the carbon market system. So the two sort of like boxed areas of the types of technologies that we found to be helpful, one is in the digital monitoring, recording, validation, DMRV sort of space. This is everything around being able to actually track whether or not activities are actually happening. So this could involve a combination of remote sensing, machine learning, AI approaches. And the other sort of broader category that's also has relevance in the carbon market space is the sort of the broader set of like Web3 technologies. So being able to actually use something like blockchain, sometimes paired with AI, to be able to actually provide end-to-end tracking of a credit over time, which is really important for avoiding something like double counting, which is one of the cases for potential fraud in the broader market system. And so I'll show you on the next slide again, like how these technologies could map to different parts of the carbon credit sort of like data lifecycle. This could involve everything from being able to actually collect the data to storing the data over time, to thinking about how to clean, structure, or index the data, various types of like algorithmic models that could be run on it, and then ultimately in the final category of contextualization, thinking about how insights could ultimately be generated. And so here, again, is I know it's a busy slide, but also happy to send you the link to the full VCM landscape guide so you could take a deeper look. But you could see how some of these technologies could be relevant. So, for example, in being able to collect the data, the remote sensing technologies are one way to be able to do that data collection on checking to see if a tree is still standing, um, make that much more accurate, being able to go and be able to pinpoint one by one, and also to make it a less resource intensive effort. I mentioned also the idea that Web3 technologies could be incredibly important because it's able to track a carbon credit throughout its entire life cycle, and be able to ensure that there isn't cases of double counting or loss in the system, et cetera, et cetera. So I think these are the places where we are already seeing instances of innovations in these technologies that are being applied across the data value chain in these ways, to be able to actually make the process not only more efficient in some cases by being able to save time and money, but oftentimes also to be able to make it more accurate, and more capable of being trusted over time. So I'll talk a little bit more about one of the big projects that our team is working on in the data space. But to dive into the problems and the challenges for what we're trying to address with that project, I'll talk a little bit more about how the current state of VCM data is. And so I reference again a little bit about how data could be hard to access, living in different spaces, buried in PDFs or siloed into various black boxes. But what also is leading to this fragmentation is the fact that all of these different players in the system use completely different formats for the data that they care about. So everything from the registry where the credit is listed, to the broker that helps facilitate transactions, to those ratings agencies that put grades on projects. Everyone has their own definition for what pieces of data they care about and in what format those that data comes in. So as you can imagine, that makes it so that it's incredibly hard to try to figure out how to compare different projects to each other, but also for this broader landscape of different stakeholders and actors in the market who do work with each other and need to be able to pass data in between each other. This is incredibly complex, and ends up taking a lot of time to figure out how you actually pass the data from one person to the next. And so that again, all of this makes it so that everyone has different parts of the data related to a credit. Not one entity has the entire full picture. And not to mention that even each of the different parts are in it's a completely different format. So putting the whole puzzle together is really, really difficult. And so that's what RMI has been working on trying to tackle over the past couple years. We've been creating what we call the carbon crediting data framework. And this is an open source, completely public good framework that we've created that organizes and structures all of the data that is important for understanding the performance of a carbon credit across its entire life cycle. And we work on both the carbon accounting components as well as non-carbon parts of data, such as biodiversity, water, community impact. So we're working on being able to standardize all of the data fields, and we've worked on structuring it in a way so that it's going to be easy to differentiate one project from another project and allow for that easy comparison. So to do this, we've pulled from more than 160 different sources, working on harmonizing and compiling. And what we've ended up with is a framework that is applicable for every single project. It doesn't matter what project type it is. And it involves at least 588 data fields for each project. So we are at an exciting phase because we are just about to finally, this is again multiple years of hard work by the team, but we're just about to launch this out into the world next month. And so what I could do is give you a quick sneak peek into what are some of these components that I'm talking about here and what types of organization that we've built. Um, we've worked on being able to organize the data fields into what we call tiers that move, that the higher the tier that you move up, the higher the level of data granularity or detail, and also the higher that you're able to move on the credit differentiation, on being able to show how your project is really performing and has the rigorous data to back it up. Um, we also are able to organize by these tiers because we recognize that depending on the user type, you tend to be working more in one tier of data versus another. And so that's another way that this organization allows for being able to understand the stage of crediting that a project is in, but also allows it to be really easy for a specific user type to determine which tier of data, up to which tier of data, should I be focusing in on. To give you a sense of what the types of data that we're working with, within each tier level, we break the data down into categories and subcategories. And here to give you a sense again of what we're talking about, diving into tier 0. This is pre-registration or the very first stage of a project before a project is even registered. These are the types of data fields within the subcategories that you would actually have the organization in. And so again, you could see the intention is no need for you to digest all of this information, but the intention is that we've built out a structure now that actually is an intuitive click-through structure that allows you to go into deeper and deeper components where all of the fields have this broader overall hierarchical organization that makes it so that it's easier to use. One of the other pieces that I mentioned is that not only did we do this data framework for all of the carbon components, so all of the important parts for being able to understand how did you actually calculate how many metric tons of carbon your project is avoiding, reducing, or removing from the atmosphere. We also saw that it was valuable to do this data framework for all of the non-carbon attributes as well. And so one of the reason why is we really do believe that a quality of a carbon credit is dependent on both the carbon as well as the non-carbon attributes. I think on one side, I, of course, come from background of working conservation and working directly with communities. And I say it's like the full picture of a carbon project. You can't think about the carbon alone. You absolutely are having broader impact, and that should play a role in when you're deciding which project to invest in. But even for the folks who care mostly about the carbon and want the math to be right there and are like, hey, a carbon project, I really care just about the carbon. The non-carbon attributes actually are incredibly important for components of a carbon project being successful. So, as for one example, it's being able to understand whether or not your project is likely to be long lasting. That's a component of a carbon credit project is durability, and the durability is something that people care a lot about. If I'm paying the money, I want to be able to have a degree of confidence that this project is going to be able to do this activity for the defined period of time. And being able to actually have community buy-in and have community voices at the table is one of the ways that you could actually have greater confidence that your project is going to be more durable and sustained over time. So there's lots of other examples like that for why the non-carbon components of a project actually are very inherent and important to the carbon portions of the project as well. So what's challenging is like if we acknowledge that these non-carbon components are important, what is challenging is that the if we thought the carbon data was tricky, what we call the social environmental data components, all of these non-carbon pieces of data are even more tricky to deal with. So at the very least with the carbon data, you do have all of these standardized methodologies for carbon projects that work on being able to define the carbon math for example, really carefully. Um, but right now, what happens is that the social environmental component really is sort of like up to the project for them to think through. It's like, hey, how am I thinking about how do I report on or share out what I'm doing? And you also have a case where then it's because it is sort of defined by the project, becomes incredibly difficult to compare from project to project. Everyone's using different ways, like what is actually the valid metric to pay attention to? Um, what happens if it's only qualitative and there's nothing quantitative that is a direct comparison you can make? And so that's one of the things that we built the carbon crediting data framework to do is that we work to actually standardize the social environmental data across 22 different categories, including things like biodiversity and water. We worked to, in all the cases where it makes sense, actually quantify the data field so that we're working with quantitative data. We also include places where we understand qualitative data makes sense. And now we're hopeful that this, by being able to create that common data language for this component of carbon projects, we're actually going to be able to allow for the VCM to place a value on these aspects of the project as well. Um, a little bit of a quick preview into some of the some of the components that are important for our team when we were thinking about how to actually create the social environmental data framework. We worked across these guiding principles across recognition, participation, and transparency. So I think that was the understanding that we want to be able to actually recognize and protect land rights of Indigenous peoples and local communities of the projects. We want to think through how there could be participation and even leadership of these local communities in the project design and in the project overall. And then finally, being super clear on how we could make that data very visible so that we could actually allow projects to differentiate themselves by their social environmental work and their impact. I will end with this note, which is we've done a lot of work, as I mentioned, years of work into actually building out this data framework, none of which is sexy, all of which is sort of, like being really, really deep in the various data fields, trying to figure out how to consolidate and reconcile and sort of wrangle. Um, and we're really excited for this moment where we're able to bring the work public now. But where we actually hope to be able to see impact is really in cases where various VCM stakeholders are actually able to use the data framework that we've created and be able to build on top of that for the various like innovative use cases that they'll like to do. So one example is Centigrade. Centigrade is a startup that is working to serve as essentially a data utility for the carbon market. What that means is that they're not involved directly in the transactions in any way. They want to be able to be a neutral party, and their function is really they want to be able to serve up the data of projects. In a really intuitive, user-friendly, easy to digest way. And so we were able to partner directly with them so that they've built their entire platform on the carbon crediting data framework that RMI has created. And so they were able to use that unsexy, but we would like to say very structurally important data framework to be able to now then build a whole user experience for being able actually look at these projects really intuitively, be able to compare project to project. So here again is a screenshot of one of their pages for one of the projects where you could see important data about the project performance that's really visually intuitive and laid out. And you could see here on another screenshot of ways that they're able to embed in pieces like the monitoring data from a cook stove project, for example. That's again really easy now to be able to understand and interpret and do the comparisons from there. And so, what we're planning to do more of is we're planning to do more of these partnerships like this, where we can make sure that the data framework actually is being implemented by various products and services within the VCM. We're also working to build consensus and coalition around the data framework. Like I mentioned, one of the things that's challenging is that various entities are using their own frameworks. And we're starting, and so like adding just another framework to the party isn't actually something that is going to be fundamentally groundbreaking. What actually will be really powerful is if we could actually get lots of these players to agree to all use one data framework together, because that's when you could truly get interoperability going. Um, and so that's what we're working to do. We're one of the leaders of the Carbon Data Open Protocol, where we're working together with 50 plus different major key priority stakeholders in the VCM, working to get everyone to create this one data framework together and agree upon using that. And so that is an area where beyond just creating our data framework and working on some of the direct implementation cases like here with Centigrade, we're also trying to figure out how we could actually drive greater consensus building across the market as a whole, which is where we think the being able to have something that's like a completely open source data framework like ours really is what's going to be a major starting piece for being able to allow that broader consensus in the market as a whole. Yeah, so that is my speed run through some of the different components of how data, technology, AI are playing a role in carbon markets. And I'm happy to open the floor up to questions now. If there's any questions from the audience, happy to chat further.
Great. Thank you, Bonnie. That was really interesting and it was a really excellent talk. So thanks a lot. Um, so yeah, like Bonnie mentioned, we're going to open it up to the audience to start our moderated Q&A. So if you have a question, please use the Q&A option that you can see at the bottom of your screen to type in a question, and then we will answer them as they come in. We have one question so far from Rainy Wood, and I'm not sure, Bonnie, if you can also open it up on your end and read it, but this question is referring to if you have heard about TIAA divest, and if that's and if that or similar efforts can be used perhaps as like point of leverage maybe. And so I looked a little bit into what this was, and it seems to be a call for a divestment of retirement savings into funding projects that might be harmful to the environment and the climate.
Yeah, great question. So I specifically haven't worked on divestment efforts myself. I definitely have like various friends who have worked on those issues. So specifically in the world of that sort of like within the credits world, like that serves as a separate lever or a separate function for folks to think through how the personal financial decisions that they're making can actually be targeted or sort of directed into different things. So yeah, so I don't have much to say on that directly since I don't work directly on that issue. But yes, that is definitely one that I know there are folks who are working on.
Okay, thanks. Thanks, Bonnie. We have a question from Darian Gill, and this is, I'm curious if you and RMI have given any thought to how your models and data may apply for a compliance market as opposed to a voluntary one. Are there efforts you're making to move the market in that direction?
Yes. Oh, really, really good question. And I think maybe the simplest answer that I could give you is that We started from where it was the most challenging. And so that's like that actually, that's the reason why our work right now has been a majority focused on the voluntary carbon market. That is where the majority of the volume of carbon credit trading, purchases, et cetera, are being done. And it also is much, much messier, as you could imagine. Like by definition, it is a voluntary market, which means like there is no centralized rules or regulations. And so that again is like that's why we started working there. There was the highest volume. It was the messiest space. And so that's where a lot of our data focused work has been targeted. Although it's like it actually like we didn't design it to be exclusively relevant for only the voluntary market. If you asked me, I would say like over time, we really need our voluntary carbon market to function much more like a compliance market. Like that's what like when we're talking about we want to bring increased trust, increased transparency, um, increased confidence. It's like all of these components are going to get to the point where there's going to be a little bit more of a convergence in that sense. And we also worked on designing our carbon crediting data framework by looking at compliance examples as well. And so I would say that this is something where over time, I wouldn't be surprised if we worked on more of a convergence across the voluntary and compliance markets. And I think it's increasingly interesting with like developments on Article 6 credits, for example, where I think that the opportunity area is going to grow by being able to work across both.
Thank you. We have another question from Brian Lee, and they are wondering if you could go back to the slide that says like data integrity needs multiple types of digital tools and technologies, and kind of walk us back through that one more time.
Yeah, give me a moment. Let me figure out how to move this slide back. Give me 1 second. Okay, here we go. Okay, I think this should.
Yep.
Data integrity. Let me figure out which slide that was again. Um, this one, I think.
Mm-hmm. That's the one.
Yeah, absolutely. Cool. So Brian, you were just interested in the formatting color. Sorry, apologies. Yeah, the intention of this was that this visual actually is directly in our VCM landscape guide. And so the intention is that this is something that you could actually process within a report versus quickly as I'm moving through slides. So note definitely taken that there's not a lot going on here. So just to break it down a little bit more. So everything that you see here in this center portion, are you able to see my mouse moving or not really?
We can see it.
Oh, great. Okay, perfect. Great. I can use this as a pointer. So everything that's here in the central box, this color coding corresponds to either the green color indicates that it's a DMRV technology. That's the ones that I mentioned that are focused on being able to do the monitoring or the validation or the reporting of activities that are actually happening on the ground. And then everything that's in this blue color, it corresponds to a Web3 technology that's focused on things such as blockchain that's able to track a credit from end to end. And so here across the top, what we have here is the different forms of data, different formats of how data is being interacted with. So it's being either collected, stored, what we call produced, which you could think of as sort of various forms of like cleanup of raw data, processing, which is the sort of like the analysis or the algorithms that you would run on the data. Contextualization would be how you actually turn the analysis into an insight you could use for a decision. So that's what's happening for the classification across this the rows at the top. Oh, sorry, the columns at the top. And then along these rows is where we break it down by the life cycle of the carbon credit. So from when you are designing a project to when you're actually registering and getting it set up with a methodology, to when you are using various forms of MRV to actually prove that the actions are happening that you say are happening, to issuance, which is when you've proven all of that, then you actually could be issued a credit. So now you actually have a credit that's capable of selling. Then the transaction step is when you actually are transacting or able to sell the credit you've been issued. And then retirement is when the buyer, say like a company that purchases a carbon credit, actually retires it so that they've quote unquote like sort of like claimed the credit or claimed the value or benefit of the credit. That's when it's retired. Was that was that helpful, Brian? Is there something that I could I'm again very happy to send out the link to the full report for anyone who's interested in diving into it further.
We're gonna assume it was Bonnie. But well, we'll send it out. Thank you. And
Good.
so another question that we have is that what excites you most about the future use of the CCDF and what do you hope for? I know you sort of touched on that towards the end
Oh,
of your talk.
yeah, I think it's like the big picture. Big picture is I would and I would say like when I say I would love for a world where the carbon markets, the full, like every single entity working within the carbon markets is all using the CCDF. And when I'm saying that, I'm saying it's like I understand that there's a lot happens in that open source community where it's like the CCDF we're putting out now, that's like, that's mostly what RMI created. We actually hope that over time it works on evolving and improving based off of the ideas of other VCM stakeholders so that it actually evolves organically over time and is built collectively by this open source community. And we get to a point where with the additional work that we're doing to facilitate convergence that everyone actually does agree to do this, agree to use this one single framework, because I think that ultimately is going to that is a fundamental piece that is going to make so much of the other tricky functions in the market so much easier. I again selfishly or from my from my personal perspective, I'm really excited about the idea of how we could actually um, put social environmental value on carbon credits. And I think that's something where there is also a movement to try to be able to break out into different credit types. So there are biodiversity credits, for example, water credits as well. And I think one of the things is the size of those markets, the number of like credits that are actually being purchased, the demand for them is much lower. And so while like long term, it's like, yeah, I would love for people to value water on its own and be able to run up a whole market just focused on that. I think what is a faster way we could move to get financing to water projects in the meantime is actually to make sure that it's valued within the carbon market where there is the most money flowing.
Thanks, Bonnie. I think you might have already actually touched on this question from Rachel King.
Oh,
And
yes.
yeah, so how do you feel about this framework being applied to the
Yes.
city credit market and what might make
Yeah.
that challenging?
Great question. I think we again, yeah, we definitely looked to the various like biodiversity credit examples as well when we were creating the biodiversity components of the data framework. I think in one of the things that we're interested in working on as a next step after we actually release the framework next month is around this idea of credit stacking, because I think this is as many of you probably know, it's like you can't work on a thing in isolation. You can't work on biodiversity in isolation and like carbon in isolation when you're really oftentimes talking about like one ecosystem or one habitat that you're working on being able to protect in some way. And so it becomes really tricky when you're trying to extract out value in that way, especially when it's the same area of land, and trying to figure out how you quote unquote make things count. And so I think one of the things we're interested in experimenting with is that there is this idea of like, hey, how could we actually do when you're working in one geographic area, how you could actually do the credit stacking. So it's sort of like even a more explicit way of like, other than just having our social environmental data being called out of like, hey, there actually is a biodiversity credit issued in this area. And what we're interested in seeing if we could get our social environmental components of the data framework to do is to allow for that stacking and then also prevent any issues of double counting across the different credit types.
Thank you. Well, I think that well, actually we don't have time for any more questions. So that was the last one and a really good one to end on. So I want to thank you again for your time and for sharing your knowledge and expertise with all of us, Bonnie. So,
Yeah, such a pleasure. So glad to be here with all of you. And again, please don't hesitate to reach out if you have any further questions. Happy to be in touch.
sweet, thank you. And for everyone online, thank you for joining. Everyone in person, thanks for joining. And we'll also be posting a recording of this talk on the NC's YouTube if you wanted to check it out again or share it with your friends. So thanks everyone for your time and attention.